Hello, and welcome to your last video of the year on 10.6, finding segment lengths in circles. My joke is just going to be at the end. It doesn't really have the right setup for the beginning and end, so you're going to have to watch the whole video to wait for it. A few vocab words here to start this lesson about segment lengths. Segments of a chord are just when, I'm just going to draw a picture in here. If two chords intersect, here, this and this are segments of that chord, and then this and this are segments of that chord. And we're going to learn a special relationship about them in this lesson. And I think this is better served with a little drawing as well. So if you have a circle, a secant, here's a tangent. This section right here, that's a secant segment. And again, we're going to learn special relationships about these. And this part is the external segment. Okay? And this, from this common endpoint, here's a secant and a tangent from a common external point. This guy here is tangent segment. Okay? All right, so let's get into it. So this first theorem talks about two chords intersecting. If two chords intersect in the interior of a circle, then the product of the lengths of the segments of one chord is equal to the product of the lengths of the segment of the other chord. So in other words, EA times EB, this guy times this guy equals EC times ED, this guy times this guy. So let's apply that in a problem down here. So we're given this diagram. Let me try to zoom in a little bit. And we want to find length ML and length JK. So we start plugging in what we know. NK times NJ is equal to NL. Remember, that's referring to the length of the segment times NM. And then we're just going to start plugging in the algebraic expressions, x plus 3, and nm is x plus 1. And then on this side of the equation, they apply the distributive property. And here we would FOIL with the result of x squared plus 4x plus 3. And if we eliminate the x squared and solve this equation, it's x equals 3. And when we substitute in that value, so for ML, these are the expressions, and then if we just plug in 3. I know you guys know how to do this part. And then 10. So again, this is one of those you always have to look back at what's being asked. If you stop here and say, well, here's x, you haven't gone far enough. You have to do the segment length. Same thing for JK. It was x. The length of JK is x, and then x plus 5, and we just plug in 3 wherever the x's were and get 11. All right, here's another one, another theorem in this lesson. So these two secants share a common point outside the circle. So there's another cool relationship here with these segments. EA times EB, the length of the whole thing. EA times EB is equal to EC times E, kind of hard to see, that's ED. Okay? That's a D here. Okay? So this times this equals this times this. You can see that we can have the opportunity for a lot of wonderful quadratic problems with this. We don't really refer to theorem numbers, but that's what they want us to put here. So we just start plugging in. Again, we're going to find the value for x. So we know that RQ times RP equals RS times RT. And we start plugging in. RQ is 6. RP is 6 plus 4. RS is 5. And RT is x plus 5. So we're going to do some simplifying. And This will be 5x and 25, and solving for x is 7. And I will let you do the checkpoints on your own if you like. If you want to, you can pause here, and then I'm just going to give you the answers. I think you guys can do this, but pause, and here come the answers. If you have questions on those, talk to me in class. Okay, last one for this lesson. It has to do with this, another, again, an external point share that is in common with a tangent and a secant. And there's another cool thing here that happens. This distance squared equals EC times ED. So this distance squared, or times itself, equals this times the whole thing. So let's look at one more sample problem where we apply that. Use the figure at the right to find distance RS, or we are solving for x here. So RQ squared equals RS times the whole segment here, RT. And let's start plugging things in that we know. 14 squared, and then that's x, and then x plus 12. Start simplifying. I'll do that one for you. 14 squared. Apply the distributive property here. And here we're going to write the equation in standard form. And this problem doesn't factor. So we're going to go ahead and use the quadratic formula. And let me plug some things in here. I hope you remember all this, right? Opposite of b plus or minus. Should I sing it? You don't want me to sing it, do you? Okay, because first because A is 1. Let me just do this, just to refresh your memory. B is 12, and C is negative 196. Just for grins, opposite of B plus or minus square root of B squared minus 4AC all over 2A. Hopefully most of you remember that. So we're just plugging in for that. Okay, we could just work on that, simplify that, plug it into our calculator, whatever we want to do, and we get negative 6 plus or minus 2 radical 58. So there was a radical that had to be simplified in there, and some reducing. This is one of those where you'd have to check back and plug in. You can't use the answer that comes to be negative. Length cannot be negative, so use the positive solution, which ends up to be this. And for this one, our book wants us to go ahead and round that to the nearest hundredth. Okay, so if you want to try this one on your own, apparently I've talked too long because this timer just went off. If you want to try this on your own, I'll give you the solution to this one as well. And then if you want, you could get a decimal for that too. All right, that's what I think we need to work on for lesson 10.6. Now my joke. A teacher asks her students, what is 3Q plus 7Q? And one of her students answered, 10Q. And the teacher said, you're welcome. So thank you for watching our videos this year, and you're welcome.